Welcome to Sleepless Philosophers, where deep ideas meet restful nights. If you enjoy these journeys through philosophy, please like and subscribe and turn on notifications for daily uploads. To support the channel, consider leaving a super thanks. Any amount helps us continue creating content. You can also become a member to request video topics. We're not monetized, so your support truly makes the difference. Now let the philosophy begin. The Simpsons paradox. A pharmaceutical company tests a new drug, comparing it to an existing treatment, and the study involves two populations, men and women, and when the results are analysed separately by gender, the new drug outperforms the old treatment in both groups. Men who take the new drug recover more frequently than men who take the old treatment, and women who take the new drug also recover more frequently than women who take the old treatment. And so it seems clear that the new drug is superior, effective for both men and women, better than the alternative, and yet when the data from both groups are combined, when the overall recovery rates are calculated across the entire study population, the old treatment appears to outperform the new drug, showing higher overall recovery rates. And this reversal, where a trend that holds in every subgroup disappears or reverses when the subgroups are combined, is Simpson's paradox, named after the statistician Edward Simpson, who described it formally in 1951, though the phenomenon had been noted earlier by others. And the paradox reveals how aggregating data can mislead, how the whole can tell a different story than the parts, and how statistical reasoning requires careful attention to confounding variables and the structure of causal relationships. The resolution of the paradox lies in understanding that the populations are not balanced, that more men than women take the new drug, or more women than men take the old treatment, or that the recovery rates differ between genders for reasons unrelated to the drugs. And this imbalance means that the overall average is dominated by the group with higher representation. And if men have higher recovery rates in general, and most men take the new drug, then the new drug will appear effective overall, even if it is actually less effective than the old treatment when gender is controlled for. Or if the distribution is skewed in other ways, the opposite reversal can occur. And the paradox shows that crude averages can be misleading. That Simpson's paradox occurs whenever there is a lurking variable, a confounding factor that influences both the treatment assignment and the outcome, and failing to account for this variable leads to incorrect conclusions. Consider a simpler example involving college admissions. Suppose a university has two departments, and Department A admits 70% of applicants, while Department B admits 30%. And when applications are examined by gender, it appears that the university discriminates against women, because the overall acceptance rate for women is lower than for men. But when the data are broken down by department, a different picture emerges. In Department A, which is less selective, a higher percentage of female applicants are admitted than male applicants, and in Department B, which is more selective, the same is true. Women are admitted at higher rates than men in both departments, and the overall appearance of discrimination arises because more women apply to Department B, which has a lower acceptance rate, while more men apply to Department A, which has a higher acceptance rate. And so even though women are favoured in both departments, they appear disfavoured overall. And this is Simpson's paradox. The confounding variable is the choice of department, which correlates with both gender and acceptance rate. And ignoring this variable produces a misleading aggregate statistic. The paradox has profound implications for how we interpret statistical data, for medical research where treatment effects can appear or disappear depending on how data are aggregated, for social science where trends in subgroups can reverse when combined, for legal cases where evidence of discrimination or bias can seem to vanish or appear depending on how populations are divided. And the paradox shows that there is no neutral or objective way to report statistics, that the choice of whether to aggregate or disaggregate, whether to control for certain variables or not, is a substantive decision that affects what conclusions can be drawn, and this decision should be guided by causal understanding, by knowledge of which variables are confounders and which are mediators. And this knowledge cannot be derived from the statistics alone, but requires background theory, domain expertise, and careful thinking about causal structure. Simpson's paradox also raises questions about the nature of causation and the relationship between correlation and causation, because the paradox shows that correlations can reverse when additional variables are considered, that associations in data are sensitive to what is held constant and what is allowed to vary, and this means that identifying causal relationships from observational data is more difficult than it might seem, that confounders must be identified and controlled for, that causal inference requires not just statistical analysis but causal modelling, the specification of hypotheses about how variables influence each other. And the paradox is one reason why randomized controlled trials are considered the gold standard for establishing causation, because randomization ensures that treatment assignment is independent of confounding variables, breaking the associations that generate Simpson's paradox. The paradox appears in many real-world contexts. In sports statistics, where a player can have a better batting average than another player in every season, yet a worse average over their entire career, because they played different numbers of games in different seasons. In economic data, where wages can increase for every demographic group, yet average wages can decrease overall, because the composition of the workforce shifts toward lower wage groups. In epidemiology, where a treatment can appear harmful overall, yet beneficial in every subgroup, because sicker patients are more likely to receive the treatment, and in each case the paradox reveals the danger of naive data interpretation, the risk of drawing conclusions from aggregate statistics without understanding the underlying structure. Some philosophers and statisticians argue that Simpson's paradox is not really a paradox, but a reminder of the importance of causal thinking, that the appearance of paradox arises only when we treat statistical associations as if they were causal relationships, that once we distinguish between correlation and causation, between conditional independence and causal independence, the paradox dissolves, and the correct answer to whether the new drug is better than the old treatment depends on the causal structure, on whether gender is a confounder that should be controlled for, or a mediator that should not be, and this depends on the mechanisms by which the drugs work and the reasons why gender affects recovery rates. Simpson's paradox has also been used to critique certain statistical practices, to question the use of aggregate statistics in policymaking, to highlight the need for transparent reporting of how data are broken down and what variables are controlled for, and to emphasize that statistical analysis is not a neutral technical exercise, but involves interpretive choices that reflect background assumptions and values, and different choices can support different conclusions, even from the same data. And this does not mean that statistics are arbitrary or that all interpretations are equally valid, but it does mean that statistical reasoning requires judgment, requires thinking about causal mechanisms, requires transparency about methods, and requires humility about the limits of what data alone can tell us. The data sit in tables, broken down by subgroups, aggregated across populations, and the numbers tell different stories depending on how they are arranged. And Simpson's paradox reminds us that statistics are not self-interpreting, that averages can mislead, that trends can reverse, and that understanding data requires more than calculation, requires causal reasoning, domain knowledge, and careful attention to structure. And the paradox persists as a warning, a puzzle that appears in textbook examples and real-world disasters, a reminder that numbers lie, or rather, that we lie to ourselves when we treat numbers as transparent windows onto reality rather than as constructed representations that must be interpreted with care. And the reversal of trends continues to surprise, continues to catch analysts off guard, continues to generate misleading headlines and faulty policies, and Simpson's paradox endures, not because the mathematics is obscure, but because the temptation to aggregate, to simplify, to collapse complex data into simple averages is overwhelming, and the paradox stands as a permanent challenge to that temptation, a proof that simplification can distort, that the whole is not always the sum of the parts, and that statistical reasoning, done properly, requires vigilance, sophistication, and an understanding of causation that transcends mere correlation. The split brain paradox. When one person becomes two, a patient suffers from severe epilepsy, seizures that cannot be controlled by medication, seizures that spread across the brain causing disability and danger, and as a last resort, surgeons perform a procedure called corpus callosotomy, severing the corpus callosum, the massive bundle of nerve fibers that connects the left and right hemispheres of the brain. And this procedure prevents seizures from spreading, confines them to one hemisphere, and after surgery the patient seems normal, speaks and acts as before, personality intact, memories preserved, and casual observation reveals no deficit. But careful testing reveals something extraordinary, something deeply strange. The two hemispheres have been separated, are processing information independently, are operating as two separate cognitive systems. And in certain experimental conditions, the hemispheres appear to have different perceptions, different knowledge, different intentions, and the patient, who was one person with one unified consciousness, before surgery now seems to be two persons, two separate centers of awareness inhabiting a single body, and this is the split brain paradox, a puzzle about personal identity, about the unity of consciousness, about whether consciousness is divisible, and about what counts as a person, and the phenomenon, discovered and studied extensively by Roger Sperry and Michael Gazzaniga, challenges our assumptions about the self, about the unity of the mind, and about whether consciousness is necessarily singular or could be plural within a single brain. Imagine the split brain setup. The patient sits before a screen and images are flashed briefly to either the left or right visual field, and because of how vision is organized, the left visual field projects to the right hemisphere and the right visual field to the left hemisphere. And normally, the hemispheres communicate through the corpus callosum, sharing information. But in split brain patients, this communication is severed, and information presented to one hemisphere is not available to the other, and the left hemisphere, which controls language, can report what it sees, but the right hemisphere, which typically lacks language, cannot speak. And this creates dissociations, cases where the person can verbally report seeing something flash to the right visual field, processed by the left hemisphere, but denies seeing anything flash to the left visual field, processed by the right hemisphere, and yet the right hemisphere clearly saw the stimulus, because when asked to point with the left hand, controlled by the right hemisphere, the patient points accurately, and so the patient both saw and did not see, both knows and does not know, depending on which hemisphere is asked. And the unity of consciousness seems to break down, seems to split into two separate streams. The paradox becomes even more dramatic in cases of conflicting intentions, where experimenters present different instructions to each hemisphere, and the left hand, controlled by the right hemisphere, performs one action while the right hand, controlled by the left hemisphere, performs another, and sometimes the hands conflict. One hand buttoning a shirt while the other unbuttons it, one hand reaching for an object while the other pushes it away, and the patient reports frustration, reports feeling as if the left hand has a mind of its own, is acting independently, and the verbal left hemisphere confabulates explanations, invents reasons for the left hand's actions, reasons that are false because the left hemisphere does not know what the right hemisphere is doing, does not have access to its intentions. And these cases suggest that split brain patients are not one person, but two persons. Two separate conscious agents inhabiting one body, each with their own perceptions, their own knowledge, their own goals, and the philosophical question is whether this is correct, whether splitting the brain splits the person, whether consciousness is divisible, whether personal identity can survive such division. Visualize consciousness before and after the surgery. Before surgery, there is one unified consciousness, one stream of awareness, experiences from both hemispheres integrated, and after surgery, this unity is broken. Each hemisphere processes information separately, and the question is whether there are now two consciousnesses, two subjects of experience, or whether there is still one consciousness that has become disconnected from some information, and different philosophers give different answers. Some argue that split brain patients become two persons, that severing the corpus callosum creates two centers of consciousness where there was one, and others argue that the patient remains one person, but with a divided consciousness, a consciousness that is no longer unified. And still others argue that consciousness remains unified, but access to information is divided, and the hemispheres are like modules within one consciousness rather than separate consciousnesses. The split brain paradox raises questions about the relationship between unity and consciousness, about whether consciousness is essentially unified or whether it could be divided or plural. And normal consciousness feels unified, feels like there is one subject experiencing everything, one perspective from which the world is viewed, and split brain cases challenge this unity, suggest that consciousness could be less unified than it seems, could be divided into separate streams that normally communicate but could operate independently. And this has implications for understanding the self, for whether the self is a unified entity or a collection of parts, for whether personal identity requires unity of consciousness or could survive division. One response to the paradox denies that split brain patients become two persons, argues that the left hemisphere, the language-dominant hemisphere, is the person, is the locus of consciousness and self-awareness, and the right hemisphere, while capable of processing information and guiding behavior, lacks the higher-order thought and self-awareness that constitute personhood. And so the patient remains one person, the left hemisphere person, and the right hemisphere is more like an unconscious module that influences behavior without being a separate conscious agent. And this response preserves the singularity of persons, but at the cost of denying consciousness to the right hemisphere. Another response accepts that split brain patients become two persons, accepts that there are two centers of consciousness after surgery, two subjects of experience, and argues that personal identity is not preserved through brain bisection, that splitting the brain creates two persons from one, and these two persons share a body, share a past, but are distinct in the present, have different experiences, different knowledge. And this response takes the split brain evidence seriously, treats the hemispheres as separate conscious systems, but faces the challenge of explaining how two persons can inhabit one body, how they coordinate, and whether one has priority over the other. A third response appeals to degrees of unity, argues that consciousness is not all or nothing unified, but comes in degrees, and split brain patients have less unified consciousness than normal people, but are not completely divided, are somewhere between one person and two, and unity of consciousness is a spectrum, and split brain patients are toward the divided end. And this response avoids the binary choice between one person and two, allows for partial division, for consciousness that is neither fully unified nor fully separate. And this seems to fit the evidence better, fits the fact that split brain patients seem mostly normal, seem like one person most of the time, but show signs of division in specific experimental conditions. The split brain paradox also connects to debates about personal identity over time, about what makes you the same person you were yesterday, about whether personal identity requires psychological continuity, and split brain cases are like thought experiments about fission made real, are actual cases where one person seems to become two, and philosophers have long debated fission cases, cases where a person's brain is divided and placed in two bodies, and asked whether the original person survives, and if so, which resulting person is the original. And split brain surgery as a partial realization of this scenario does not create two separate bodies, but does create two separate information processing systems, and the philosophical puzzles about fission apply to split brain cases, puzzles about identity, about survival, about what matters in personal existence. The patient lives with split brain, navigates the world, seems normal to observers, and most of the time, the two hemispheres cooperate through shared subcortical structures, through behavioral coordination, through learned patterns, and the division is not apparent. But in the laboratory, under controlled conditions, the split emerges. The two hemispheres reveal their independence, and the paradox appears: one person or two, unified or divided, single consciousness or dual, and the answer remains disputed, remains unclear. And the split brain paradox endures as one of the most fascinating and philosophically significant phenomena in neuroscience, a real-world case that challenges our understanding of consciousness, of unity, of personal identity, and of what it means to be one person rather than many. And the severed corpus callosum sits there, two hemispheres separated, and the question persists: is this one mind or two? And the paradox remains unsolved, perhaps unsolvable, a permanent puzzle about the nature of self and consciousness. The surprise examination paradox. A teacher announces to a class on Friday afternoon that there will be a surprise examination sometime during the following week, and the examination will be a surprise in the sense that the students will not know on which day it will occur until the morning of the examination itself. And this announcement seems straightforward, even cruel perhaps, but harmless from a logical standpoint. Yet one clever student raises a hand and argues that the surprise examination is impossible, that it cannot occur, and the reasoning goes as follows. The examination cannot be on Friday, because if it has not occurred by the end of Thursday, then the students will know it must be on Friday, and therefore it will not be a surprise, and if Friday is ruled out, then the examination cannot be on Thursday either, because if it has not occurred by the end of Wednesday, then the students will know it must be on Thursday, since Friday has been eliminated, and therefore it will not be a surprise. And this reasoning continues backward through the week, eliminating Wednesday, Tuesday, and Monday in turn, until the student concludes that the surprise examination cannot occur on any day of the week, that the teacher's announcement is self-contradictory, that a surprise examination is logically impossible. The class relaxes, confident in this reasoning, and then on Wednesday morning the teacher administers the examination, and the students are indeed surprised, and this outcome seems to vindicate the teacher and refute the student's argument. Yet the student's reasoning appeared sound. Each step seemed to follow logically from the previous one, and so a paradox emerges. The surprise examination both is and is not possible. The student's proof that it cannot occur is seemingly valid, yet the examination does occur and is genuinely surprising, and philosophers and logicians have puzzled over this paradox for decades, proposing various resolutions but reaching no consensus. One approach is to question what surprise means, to argue that the student's reasoning equivocates between different senses of surprise or knowledge, that ruling out Friday does not give the students the kind of knowledge that would make Thursday non-surprising, because the teacher could change plans, could decide not to give an examination at all, could be mistaken about the week, and so even if the students can deduce that the examination must be on Thursday if it occurs that week, they do not know with certainty that it will occur, and this residual uncertainty preserves the possibility of surprise. Another approach focuses on the self-referential nature of the announcement, arguing that the student's reasoning involves a kind of paradox of self-reference, similar to the liar paradox, because the teacher's announcement refers to the student's knowledge state, claiming that they will not know when the examination occurs, and the student's reasoning attempts to derive knowledge about the examination from the announcement itself, creating a loop where the truth of the announcement depends on whether the students believe it, and this loop generates instability, making it impossible to consistently assign truth values to the claims involved. Still another approach suggests that the student's backward induction reasoning is flawed, that while it is true that the examination cannot be on Friday, if the students know this in advance, the elimination of Friday does not straightforwardly imply that Thursday can also be eliminated, because the reasoning that rules out Thursday depends on the students believing that Friday is ruled out. But if the examination could in fact occur on Friday, despite the reasoning, then the entire chain of deductions collapses. And this highlights a problem with self-fulfilling or self-defeating prophecies, situations where believing a conclusion affects whether the conclusion is true. The surprise examination paradox also connects to issues in epistemic logic, the formal study of knowledge and belief, because the paradox involves nested levels of knowledge. The teacher knows that the students do not know when the examination will occur, the students know that the teacher knows this, and so on, and reasoning about such nested knowledge structures is notoriously tricky, prone to paradoxes and fallacies, and formal epistemic logic provides tools for analysing these structures, but also reveals their complexity and the ease with which intuitive reasoning can go astray. The paradox has applications beyond the classroom, appearing in game theory and strategic reasoning, where players must reason about what other players know and believe, and where backward induction arguments, similar to the students' reasoning, are used to solve sequential games. But these arguments can lead to counterintuitive results, situations where seemingly sound reasoning produces predictions that are violated in practice, and the surprise examination paradox serves as a cautionary tale about the limits of such reasoning. The paradox also raises questions about the nature of surprise itself, whether surprise is a psychological state, a relation between expectations and events, or a logical property of statements and situations, and whether it is coherent to announce in advance that something will be surprising, because the act of announcing seems to undermine the surprise, yet in practice, surprise examinations do occur and are surprising, and so perhaps surprise is not as fragile as the student's reasoning suggests. Perhaps it is compatible with some forms of foreknowledge, with knowing that something will happen without knowing when or how. The teacher's announcement, the student's reasoning, and the actual occurrence of the examination on Wednesday form a triangle of tension, each element seemingly incompatible with the others, yet all actually occurring, and the paradox remains unresolved, a puzzle that continues to generate papers and debates, a simple scenario that conceals deep issues about knowledge, belief, time, and the logic of self-reference. And it stands as a reminder that reasoning, even careful logical reasoning, can lead us astray when the premises involve reflexive concepts, when statements refer to their own truth or to the knowledge states of those who hear them, and that the gap between theory and practice, between what logic seems to prove and what actually happens, can reveal faults in our logical frameworks or in our understanding of concepts like knowledge and surprise, or perhaps in the very idea that logic can fully capture the complexities of situations involving human belief and expectation, and the examination comes unexpected despite the announcement, surprising despite the reasoning, and the students, shocked and unprepared, realize that the paradox is not merely abstract but painfully real, and the teacher smiles, victorious, having somehow managed to do the impossible, to give a surprise examination that was announced in advance, and yet remained a surprise, and the paradox endures, unsolved and perhaps unsolvable, a crack in the edifice of logical reasoning that no amount of analysis has yet managed to seal. The third man argument, why Plato's theory spawns infinite forms. A philosopher named Aristotle attacks his teacher, Plato's theory of forms, attacks the idea that universal properties like tallness or humanity exist as perfect eternal forms in a separate realm, and Aristotle constructs a devastating objection, an argument that shows Plato's theory generates an infinite regress, creates an endless multiplication of forms, and the argument is called the third man argument, named after an example involving men, and the argument goes as follows. Plato says that multiple tall men are tall because they participate in the form of tallness. They resemble the form. They share something with the eternal perfect tall. And now Aristotle asks, if multiple men and the form of man are all men in some sense, then what explains their similarity? What makes them all instances of manhood? And Plato's theory requires positing another form, a second form of man that the first form and the particular men all participate in. And this second form explains why the first form and the particulars are all men. But now we have the second form and the particular men and the first form, and these are all men. And what explains their similarity? And Plato's theory requires a third form, a third man, and this generates infinite regress, infinite forms, and the explanation never grounds, never stops, never reaches a final form that explains all similarity. And this is the third man argument, a reductio ad absurdum of Plato's theory of forms, showing that the theory is self-defeating, generates infinite regress, and cannot explain what it was designed to explain. Imagine the structure. Multiple particular tall men exist. Call them Tom and Tim and Ted. And they are all tall, and Plato explains this by saying they all participate in the form of tallness. Call it Form 1. And Form 1 is the perfect tall, is what makes Tom and Tim and Ted tall. And they are tall by resembling Form 1. But now notice that Tom and Tim and Ted and Form 1 are all tall. All share the property of tallness. And by Plato's own reasoning, this similarity requires explanation, requires a form that they all participate in. And so we need Form 2, a second form of tallness that explains why Form 1 and the particular men are all tall. And now we have Form 1 and Form 2 and the particular men, all tall. And this similarity requires explanation, requires Form 3. And the regress continues infinitely. And tallness is not explained by a single form, but by an infinite hierarchy of forms. And this infinite hierarchy is vicious, is problematic, because each form was supposed to explain similarity, was supposed to ground the property, but the grounding never completes, requires further forms endlessly. The third man argument reveals a deep problem with Plato's theory. The problem is that forms are supposed to explain why particulars have properties, but forms themselves have properties. The form of tallness is tall, the form of beauty is beautiful. And if forms have the properties they explain, then they fall under their own domain, are subject to the same explanation they provide. And this creates regress, creates the need for higher order forms. And the regress is vicious because it undermines the explanatory role of forms, shows that forms do not actually explain anything, do not provide ultimate ground. And Aristotle uses this argument to reject Plato's separate forms, to argue that forms must exist in particulars, not in a separate realm, and that resemblance is primitive, not explained by participation in forms. Visualize the regress as a ladder. At the bottom are particular tall men. At the next rung is Form 1 that explains their tallness. At the next rung is Form 2 that explains why Form 1 and the men are all tall. At the next rung is Form 3, and the ladder extends infinitely upward, never reaching a final rung, never grounding the explanation. And climbing the ladder does not bring us closer to understanding tallness, only pushes the question higher. And the third man argument shows that Plato's theory is a ladder to nowhere, is an explanatory structure that generates infinite regress rather than providing genuine explanation. One response to the third man argument, a response Plato himself may have considered, denies that forms have the properties they explain, denies that the form of tallness is itself tall, argues that forms are paradigms, are perfect standards, but do not instantiate the properties they ground. And the form of tallness is not tall, but is what tallness is the nature of tallness. And particulars are tall by resembling the form, but the form does not resemble itself, does not participate in itself. And this blocks the regress because there is no need to explain why the form and the particulars are both tall. The form is not tall, and only particulars are tall, and the regress does not start. And this response requires distinguishing between being a property and instantiating a property, requires that forms be properties without having properties. And this is metaphysically subtle, requires careful formulation. Another response accepts that forms instantiate themselves, accepts that the form of tallness is tall, but denies that this requires further explanation, denies that the form and particulars being tall needs to be explained by a higher form, argues that the form is self-explanatory, is the ground of tallness, and the fact that the form is tall is not a further fact requiring explanation, but is constitutive of what the form is, and this response blocks the regress by denying the premise that all similarity requires explanation, allows that some similarity is primitive, is not explained by further forms, and the form of tallness being tall is primitive, grounds other tallness, but does not itself need grounding. A third response from Aristotle's own position rejects Plato's separate forms entirely, argues that universals exist in particulars not in a separate realm, and tallness exists in tall men, is immanent, not transcendent. And this avoids the third man regress because there is no separate form that is itself tall. Forms are not separate entities but are aspects of particulars, and the regress does not arise because there is no form that shares the property with particulars. And Aristotle's immanent realism avoids the third man argument by changing the metaphysical location of universals, putting them in the world rather than in a separate realm. The third man argument has influenced debates about universals throughout history, has been revived and refined, has been applied to various theories of properties, and the argument shows that any theory that posits entities to explain resemblance must be careful not to make those entities instances of what they explain, must avoid the structure that generates regress, and modern theories of properties, trope theories, and resemblance nominalism and immanent realism all have been shaped by the need to avoid the third man regress. All have been designed to explain properties without generating infinite hierarchies. The argument also appears in discussions of sets and classes, because Russell's paradox is structurally similar, asks whether the set of all sets that do not contain themselves contains itself, and generates contradiction, and avoiding Russell's paradox requires type theory or other restrictions that prevent sets from being members of themselves, and these restrictions are analogous to the restrictions needed to avoid the third man argument, are ways of preventing entities from falling under their own domain, and both paradoxes show that self-reference creates problems, creates regress or contradiction, and metaphysical theories must be structured to avoid self-application. Plato's forms stand in the realm of perfect ideas, tall and beautiful and just, and the particular men stand in the physical world, tall by participation in forms, and the third man appears. The need for a second form to explain why the first form and the men are similar, and then the fourth man, the fifth, infinite, regress, and Aristotle's argument stands, devastating and elegant, showing that Plato's theory contains internal incoherence, generates infinite regress, and cannot provide the explanation it promises. And the third man argument endures as one of the most famous arguments in ancient philosophy, an argument that shaped the development of metaphysics, influenced all subsequent theories of universals, and remains a permanent challenge to any theory that posits abstract entities to explain similarity. And the third man waits, hovering above the first and second, and the regress continues, and Plato's theory falters, and the argument persists. The twin paradox: why space travel keeps you young. Two twins stand together on Earth, both 20 years old, identical in age and appearance, and one twin boards a spaceship that accelerates to nearly the speed of light, travels to a distant star, turns around and returns to Earth, while the other twin stays home. And when the travelling twin steps off the spaceship, expecting to greet their sibling who is the same age, they discover something shocking. The twin who stayed on Earth has aged 40 years and is now 60 years old, while the travelling twin has aged only 10 years and is now 30. And this asymmetric aging is not science fiction, but a genuine prediction of Einstein's special relativity, confirmed by countless experiments with atomic clocks and particle accelerators. And yet it seems paradoxical, because relativity also says that motion is relative, that there is no absolute reference frame, that the travelling twin could equally well say they were at rest while Earth moved away and then returned. And by this reasoning, the Earthbound twin should be younger, and so both twins should expect the other to be younger. And this contradictory expectation is the twin paradox, a puzzle that has generated confusion and debate since Einstein first proposed special relativity in 1905. Imagine watching the travelling twins' journey from Earth. You see the spaceship accelerate to 80% of light speed, and time dilation occurs. A clock on the spaceship runs slower than clocks on Earth, ticking at 60% of the normal rate. And this is not an illusion or a trick of observation, but a genuine physical effect. Time itself passes more slowly for objects in motion, and so during the 10 years of ship time that the travelling twin experiences, 16 years pass on Earth, and when the ship turns around and returns, another 16 years pass on Earth, while only another 10 years pass on the ship. And the total is 40 years on Earth and 20 years on the ship. And the asymmetry is real. The travelling twin really has aged less. Their biological processes ran slower, their heartbeats were slower, their thoughts were slower. Everything about them unfolded in slow motion from Earth's perspective, though from their own perspective, nothing felt different. Time seemed to pass normally, but less of it passed. Now consider the situation from the travelling twins' perspective, and here is where the paradox seems to bite. Because from the ship's viewpoint, Earth is the object in motion. Earth accelerates away, then turns around and comes back, and by the symmetry of relativity, the travelling twin might expect Earth clocks to run slower, might expect the Earthbound twin to age less, and yet the prediction is the opposite, and the resolution is that the situation is not actually symmetric. The travelling twin accelerates, feels forces, experiences changes in velocity, while the Earthbound twin remains in an inertial reference frame, floating freely in space, not accelerating, and this asymmetry breaks the apparent symmetry of the situation. Special relativity applies only to inertial frames, frames moving at constant velocity, and the travelling twins' frame is not inertial. They accelerate when leaving, accelerate when turning around, and accelerate when stopping back at Earth. And these accelerations make the travelling twins' frame fundamentally different from the Earthbound twins' frame. And general relativity, which handles accelerated motion, confirms that the travelling twin ages less. The accelerations cause additional time dilation effects that accumulate during the turnaround, and the overall result is that the travelling twin is younger. Visualize the journey on a space-time diagram. With time running vertically and space running horizontally, the Earthbound twins' world line is a straight vertical line, moving forward in time but not in space, while the travelling twins' world line is a bent path, going up and to the right as the ship travels away, then bending at the turnaround point, then going up and to the left as the ship returns. And the key insight is that in space-time, the proper time experienced by an observer, the time measured by their own clock, is the space-time interval along their world line. And this interval is maximised for straight paths and minimised for bent paths, exactly the opposite of spatial geometry, where straight lines are the shortest distance. And so the bent world line of the travelling twin corresponds to less elapsed time. They experience fewer years because their path through space-time is longer in space but shorter in time. And this is not a matter of perspective or coordinate choice, but a geometric fact about space-time, an invariant quantity that all observers agree on. The paradox has been tested experimentally, not with human twins but with atomic clocks in the Hafele-Keating experiment. In 1971, atomic clocks were flown around the world on commercial airliners and compared with clocks that remained on the ground, and the flying clocks showed less elapsed time, exactly as relativity predicted. The effect was tiny, measured in nanoseconds, because the planes were slow compared to light speed, but it was measurable and confirmed the theory, and similar experiments have been done with clocks on satellites, with GPS systems which must account for time dilation to function accurately, with particles in accelerators whose lifetimes are extended by time dilation. And in every case, the predictions of relativity are confirmed. Moving clocks run slow, and the effect is real and cumulative. The twin paradox also raises questions about space travel and the possibility of reaching distant stars, because time dilation means that from the perspective of travellers on a fast spaceship, the journey to a star 10 light-years away need not take 10 years. If the ship travels at 99% of light speed, the travellers experience only about 1.5 years of travel time. The distance contracts in their frame. They see the universe compressed along the direction of motion, and they cross the 10 light-years in a fraction of the time it would take at lower speeds, and so interstellar travel is theoretically possible within human lifetimes, at least from the traveller's perspective. Though when they arrive home, they will find that decades or centuries have passed on Earth, their friends and family aged or dead, and this asymmetry, while not a logical contradiction, creates a deep emotional and philosophical tension. The travellers experience only a few years, but return to a world that has moved on without them. Some people respond to the twin paradox by rejecting relativity, by insisting that time is absolute, that both twins must age the same amount, that the theory must be wrong. But this response ignores the overwhelming experimental evidence, the thousands of confirmations in particle physics, astrophysics, and technology. The fact that relativity is one of the most thoroughly tested theories in all of science, and the predictions have never failed. And so the paradox is not a refutation of relativity, but a counterintuitive consequence that we must accept. And the strangeness of the result reflects the strangeness of the universe, the fact that time and space are intertwined, that time is not absolute but relative, that duration depends on motion, and that the universe operates according to rules that defy everyday intuition. The twins stand together again, one young and one old, and the younger twin has travelled through space and time, has experienced the compression of years into months, has returned to find the future arrived, and the paradox is resolved. There is no contradiction, only an asymmetry. The travelling twin accelerated, and the earthbound twin did not. And this difference explains everything, makes the situation non-symmetric, removes the paradox, and yet the strangeness remains. The fact that time is not fixed, that motion affects aging, that twins can end up different ages by taking different paths through space-time. And the twin paradox endures as a teaching tool, as an illustration of relativity's most counterintuitive predictions, as a thought experiment that has become reality through atomic clocks and particle decays, and as a reminder that the universe is stranger than common sense suggests, that time is not what we thought it was, and that the path you take through space-time determines how much time you experience, how much you age, how much life you live. And the travelling twin, younger by decades, stands as proof that Einstein was right, that time dilation is real, and that space travel, if we ever achieve the speeds required, will make astronauts into time travellers, moving forward into Earth's future while aging only slightly themselves. And the paradox, resolved but never fully domesticated, remains a monument to the weirdness of relativity and the malleability of time. The white crow paradox, when one exception destroys everything. The statement "all crows are black" is a universal generalization, claims that every member of a class has a certain property, and to confirm this hypothesis, we observe crows, find black ones, and each observation of a black crow provides some evidence that all crows are black. And as the observations accumulate, as we find hundreds or thousands of black crows and no non-black ones, our confidence grows. The hypothesis seems increasingly well supported, and this is standard inductive reasoning, generalizing from observed to unobserved cases, and yet there is an asymmetry, a striking difference between confirmation and refutation, because while confirming a universal generalization requires many observations, observing instance after instance, refuting it requires only one, requires finding a single counterexample, a single white crow, and this one observation destroys the hypothesis completely, shows definitively that not all crows are black, and this asymmetry between confirmation and refutation is sometimes called the white crow paradox, or the black swan problem, named for the discovery of black swans in Australia, which refuted the European belief that all swans are white, and the paradox highlights the logical asymmetry between universal and existential claims, between all and some, and raises questions about the rationality of holding universal beliefs based on limited evidence. Imagine searching for crows, observing thousands of them, recording their colours, finding only black crows, never seeing any crow that is not black, and based on this evidence concluding that all crows are black, and this inference seems reasonable, seems justified by the evidence, and yet it is logically vulnerable because it only takes one white crow, one single observation to prove the inference wrong, to show that despite thousands of confirming instances, the generalization was false. And this vulnerability is not unique to the crow hypothesis, but characterizes all universal generalizations, all claims of the form, all X are Y, and it raises the question of whether we should believe such generalizations at all, whether induction can ever justify universal claims, or whether we should limit ourselves to weaker claims, like all observed crows are black, or most crows are probably black, claims that cannot be refuted by a single counterexample. Visualize the logical space with confirmation as a gradual process, slowly accumulating evidence, moving toward but never reaching certainty, and refutation as instantaneous, a single observation that immediately establishes falsity. And this asymmetry is fundamental to the logic of universal and existential quantification, because to prove all crows are black requires checking every crow, which is impossible if there are infinitely many crows or even just too many to observe, while to prove some crows are not black requires finding only one. And so existential claims are verifiable but not falsifiable, can be proven true but not proven false, while universal claims are falsifiable but not verifiable, can be proven false but not proven true. And this asymmetry shapes scientific practice, shapes how we test theories, and Karl Popper built an entire philosophy of science around it, arguing that scientific theories should be universal claims that are falsifiable, that science progresses not by confirming theories, but by attempting to refute them, and theories that survive refutation attempts are corroborated though never confirmed. The white crow paradox connects to the problem of induction, to Hume's challenge, because induction moves from observed instances to unobserved generalizations, from particular to universal, and this move is never logically justified, can never guarantee that the conclusion is true even if all premises are true, and the possibility of a white crow, the possibility that the next observation will refute the generalization, is always present, can never be eliminated, no matter how many confirming instances we have observed. And this makes universal generalizations perpetually tentative, perpetually vulnerable. And some philosophers conclude that we should never fully believe them, should always maintain some doubt, should treat them as useful working hypotheses, rather than as established truths. The paradox also raises questions about the psychology of belief, about why we do believe universal generalizations despite their vulnerability, about why finding thousands of black crows leads us to believe that all crows are black, even though we know this belief could be refuted tomorrow by a single white crow. And the answer involves practical reasoning, involves the need to act and make decisions based on limited information, involves the fact that treating all crows as black, until proven otherwise, is useful, allows us to make predictions and navigate the world, and the cost of being wrong, of encountering a white crow, is usually low, does not justify the cognitive burden of maintaining constant skepticism, and so we believe universal generalizations not because they are logically justified, but because they're practically useful, because acting as if they are true works well enough most of the time. The asymmetry between confirmation and refutation has been used to argue for various methodological principles. Popper's falsificationism says scientists should focus on trying to refute theories rather than trying to confirm them, should design crucial experiments that could show theories wrong, should prefer theories that make bold predictions that could easily be falsified. And this methodology treats the asymmetry as central, builds scientific method around the ease of refutation compared to the difficulty of confirmation. Though critics argue that Popper's philosophy does not match actual scientific practice, that scientists do seek confirming evidence, do not merely attempt refutation, and that confirmation and refutation both play roles in science, are complementary rather than opposed. The white crow appears rare and shocking, and the hypothesis that all crows are black crumbles instantly. Years of observations rendered irrelevant by a single exception, and this dramatic reversal, this sudden collapse of belief, illustrates the fragility of universal generalizations, the precariousness of inductive inference, and the paradox is not that refutation is easy, but that we believe universal generalizations at all given how easily they can be refuted, given that we can never observe all instances, given that the next observation might always be the white crow that destroys our confidence. And yet we do believe, we do generalize, we do infer from observed to unobserved, because we must. Because thinking and acting require going beyond immediate experience, require making assumptions about regularity, about patterns continuing, about the unobserved resembling the observed, and the white crow paradox stands as a reminder that these assumptions are always vulnerable, always tentative, always subject to refutation by new evidence, and that science progresses not by establishing certainties but by proposing hypotheses that survive testing, that withstand attempts at refutation, that continue to work until they do not, and the search for white crows continues. The search for exceptions, for counterexamples, for anomalies that challenge generalizations, because finding them is how we learn, how we improve theories, how we discover that what we thought was universal is merely local, that what we thought was necessary is merely contingent, and the white crow paradox endures as a lesson about the limits of induction, about the asymmetry between proof and disproof, and about the tentative nature of all empirical knowledge. Buridan's ass. When perfect balance creates perfect paralysis. A donkey stands exactly halfway between two identical bales of hay, equidistant from both, and the donkey is hungry, equally attracted to both bales, and both bales are identical in size, quality, freshness, and appeal, and there is no reason to prefer one over the other, no difference that would make choosing one more rational than choosing the other. And according to the principle of sufficient reason, the idea that every choice must have a reason, that rational action requires a reason to prefer one option over alternatives. The donkey cannot choose because choosing either bale would be arbitrary, would be action without sufficient reason, and so the donkey stands paralyzed, unable to move toward either bale, and eventually starves to death despite being surrounded by food. And this is Buridan's ass, a thought experiment in medieval philosophy, named after Jean Buridan, though the paradox predates him, and it illustrates a problem with certain models of rational choice, shows that if rationality requires sufficient reason for every choice, then perfect symmetry creates paralysis, creates situations where rational action becomes impossible. Imagine the donkey's perspective, looking left at one bale, looking right at the other, evaluating, comparing, and finding them perfectly equal. no basis for preference, no reason to go left rather than right or right rather than left. And the principle of sufficient reason says that to act rationally, the donkey needs a reason, needs something that makes one option better. And in the absence of such a reason, the donkey should not act, should remain neutral, should not arbitrarily favour one identical option over another. And so the donkey stays in place, and the bales remain equidistant, and time passes, and hunger grows, but still no reason emerges to break the symmetry. And the donkey, committed to rational decision-making, committed to acting only when there is sufficient reason, cannot move, and the commitment to rationality becomes a death sentence. The paradox challenges the principle of sufficient reason, challenges the idea that rational action always requires a reason to prefer one option over alternatives. Because in situations of perfect symmetry, there is no such reason, and yet acting is better than not acting. Choosing either Balo is better than choosing neither, and survival requires breaking the symmetry. Somehow requires choosing arbitrarily, and if arbitrary choice is allowed, then the principle of sufficient reason is false, is not a requirement of rationality, and if arbitrary choice is not allowed, then rationality becomes self-defeating in symmetric situations, becomes a principle that prevents beneficial action, and neither option is attractive. Neither preserves our intuitions about what rationality requires. Visualize the situation as a balance, perfectly level, with equal weights on both sides, and the donkey as the fulcrum, unable to tip in either direction because the forces are equal. And tipping requires an imbalance, requires one side to outweigh the other, but no such imbalance exists, and so the balance remains level, and the donkey remains centered. And the metaphor captures the paralysis, the inability to move, when reasons are perfectly balanced, when no consideration favors one option over another. One response to the paradox is to deny that such perfect symmetry ever occurs in reality, to argue that there are always small differences, imperceptible perhaps, but sufficient to break ties. One bale is slightly closer or slightly greener, or catches the light differently. And even if these differences are too small to consciously notice, they provide sufficient reason for the unconscious decision-making processes that guide action, and so real donkeys never face perfect symmetry, never actually starve between identical bales, because nothing in nature is perfectly identical. And the paradox is a thought experiment that does not correspond to any actual situation. And while this may be true for physical objects, the paradox still applies to abstract choices, where perfect symmetry can be stipulated, and so the response avoids the real problem rather than solving it. Another response is to modify the principle of sufficient reason to allow arbitrary choice in symmetric situations, to say that rationality requires reasons to prefer one option over another when such reasons exist, but when options are genuinely equal, then arbitrary choice is rational, is indeed the only rational response. And in cases of perfect symmetry, choosing randomly is not irrational, but is the rational thing to do. And the donkey should flip a mental coin, should pick arbitrarily, should recognize that in the absence of reasons to distinguish between options, any choice is as good as any other, and making an arbitrary choice is better than making no choice. And this response preserves rationality while allowing action in symmetric cases. But it requires weakening the principle of sufficient reason, requires admitting that not all rational actions have reasons, that sometimes the rational thing is to act arbitrarily. A third response appeals to higher order considerations, argues that even when two options are equally good in terms of immediate outcomes, they may differ in terms of meta-level features, and the donkey should consider not just which bale to eat, but also principles of decision-making, and there are good reasons to have a policy of breaking ties somehow, perhaps always choosing the left option in symmetric cases, or always choosing randomly, and having such a policy provides sufficient reason to choose even when the options themselves provide no reason. And the donkey, who has adopted the policy of going left in symmetric situations, has a reason to go left. The reason is not that the left bale is better, but that the policy says to go left. And this preserves sufficient reason at a higher level while allowing action at the object level. But it raises questions about where the higher level policy comes from, whether adopting the policy itself requires sufficient reason, and whether we have just pushed the problem back one level without solving it. The paradox also connects to debates about free will and determinism, because if every choice requires a sufficient reason, a cause that explains why that choice was made rather than another, then in situations of perfect symmetry, no choice can be made. And yet humans and animals do make choices in such situations, do break ties, and this suggests that not all choices are determined by reasons, that there is some indeterminacy, some capacity for arbitrary choice, and libertarians about free will embrace this, argue that free will requires the ability to choose without sufficient determining reasons, requires that agents can tip the balance even when reasons are equal, but compatibilists and determinists argue that apparent symmetry is always broken by hidden factors, by unconscious preferences or random neural fluctuations, and what looks like arbitrary choice is actually determined by factors we do not consciously access. The paradox appears in practical contexts involving decision-making under uncertainty, where multiple options have equal expected value, and decision theory must specify what to do in such cases. And most theories say to choose randomly, to treat equal value options as interchangeable. And this is the rational response, but it requires abandoning the strong version of sufficient reason. Requires accepting that rational choice sometimes is arbitrary choice, and this has implications for ethics and policy, for situations where multiple actions are equally good, where no moral consideration distinguishes between them. And in such cases, acting is better than paralysis, and any permissible action can be chosen without need for further justification. The donkey stands motionless, hunger gnawing, hay on both sides, and the commitment to sufficient reason becomes a trap, becomes a principle that prevents survival, and the paradox remains, challenging rationality, forcing recognition that reason has limits, that symmetry creates problems, that pure rationality cannot solve. That arbitrary choice, far from being irrational, is sometimes the only rational response. And Buridan's ass endures, starving between equal bales, a symbol of the perils of excessive rationality, of the dangers of demanding reasons when none exist. And the paradox persists as a reminder that action requires more than reason, requires the capacity to break ties, to choose when choices are equal, to act despite the absence of sufficient reason. And rational agents, whether donkeys or humans, must possess this capacity or risk paralysis, risk standing frozen while opportunities pass and the ass remains, hypothetical but instructive, teaching that rationality is not just about having good reasons, but also about knowing when reasons run out and arbitrary choice must begin. Yablo's paradox. In 1993, the philosopher Stephen Yablo introduced a paradox that seemed impossible, a self-referential contradiction that contains no self-reference at all, a loop without a loop. And this paradox has troubled logicians ever since because it challenges the assumption that all semantic paradoxes arise from statements referring to themselves. Imagine an infinite sequence of sentences, each one numbered, and each sentence says the same kind of thing. Sentence 1 says for all sentences after this one, at least one of them is false. Sentence 2 says for all sentences after this one, at least one of them is false. Sentence 3 says the same, and so on forever, each sentence making a claim about all the sentences that come after it, but never referring to itself or to any sentence that comes before. Now consider whether sentence 1 is true. If it is true, then at least one sentence after it must be false. So sentence 2 or 3 or some later sentence must be false. But sentence 2 makes the same claim as sentence 1, just shifted down the sequence. So if sentence 2 is false, then all sentences after it must be true, but sentence 3 says at least one sentence after it is false, which contradicts the idea that all sentences after sentence 2 are true, and so sentence 2 cannot be false. And the same reasoning applies to every sentence in the sequence. None of them can be false without contradiction, which means all of them must be true. But if all of them are true, then sentence 1's claim that at least one sentence after it is false must itself be false, and so we arrive at a contradiction without any sentence ever referring to itself. The paradox is startling because it was long believed that self-reference was the root of all semantic paradoxes, that statements like "this sentence is false" create problems precisely because they loop back on themselves. But Yarblough's paradox suggests that infinite chains of reference can generate the same kind of contradiction, even when each individual sentence only points forward, never backward. Some philosophers argue that Yarblough's paradox is secretly self-referential after all, that the infinite sequence as a whole refers to itself in some implicit way, or that each sentence indirectly refers to itself through the mediation of the sentences that follow. But others insist that the paradox is genuinely non-self-referential, that it reveals a new kind of logical pathology that cannot be explained by the old models. The paradox has deep implications for theories of truth, because if self-reference is not necessary for paradox, then many proposed solutions to the liar paradox and related problems must be reconsidered, and new strategies must be developed to handle infinite structures that generate contradiction through endless forward reference, rather than immediate loops. Some logicians suggest that the paradox arises because we are treating an infinite sequence of statements as if it were a completed whole, and that in a finite or constructive framework, the paradox would dissolve, while others embrace infinitary logic and try to develop formal systems that can accommodate Yarblough's structure without collapsing into inconsistency. The paradox also connects to issues in recursion theory and computer science, where infinite loops and non-terminating processes can exhibit similar behavior, generating contradictions or undefined results, without any single step referring back to a previous one. Yarblough's paradox stands as a reminder that infinity is strange, that logic stretched across endless sequences behaves in ways that defy intuition, and that the boundaries of coherent thought may be more fragile than we imagined, that even without the familiar twist of self-reference, language and logic can still tie themselves into knots from which there is no escape. Frankfurt's counterexamples. When you're responsible. Even though you had no choice, a person decides to perform an action, decides on their own, without coercion, based on their own reasons and desires, and they perform the action, and we say they are morally responsible. They acted freely. They deserve praise or blame for what they did. And traditional theories of moral responsibility say that responsibility requires the ability to do otherwise, requires that the person could have chosen differently, that they had genuine alternatives, and this principle, called the principle of alternate possibilities, seems obvious, seems essential to responsibility, because how can you be responsible for an action if you had no choice, if you were forced to do it, if no alternative was possible? And yet philosopher Harry Frankfurt constructed examples that challenge this principle. Examples where a person acts on their own, makes their own decision, but could not have done otherwise, and yet intuitively seems responsible. And these are Frankfurt's counterexamples, thought experiments designed to show that the principle of alternate possibilities is false, that responsibility does not require the ability to do otherwise, that what matters is how you acted, whether the action flowed from your own will, not whether you could have acted differently. And Frankfurt's cases have been enormously influential, have reshaped debates about free will and responsibility, have challenged incompatibilist arguments that say determinism undermines responsibility, and the counterexamples remain controversial, remain debated, but have permanently changed the landscape of discussions about freedom. Imagine the example. A person named Jones decides to perform an action, decides to vote for a certain candidate, and Jones makes this decision on his own, based on his own political views, his own deliberation. No one forces him, no one coerces him, and he goes to vote, and he is about to vote for the candidate he chose. And at this moment, unbeknownst to Jones, there is another person, call him Black, who has been monitoring Jones's brain states, and Black has the ability to intervene, to manipulate Jones's brain, to force Jones to vote for the candidate if Jones shows signs of changing his mind, and Black is prepared to intervene but does not need to, because Jones votes for the candidate on his own, makes the decision himself, and Black's intervention mechanism remains dormant, unused. And the question Frankfurt asks is whether Jones is morally responsible for his vote. And intuitively, the answer is yes. Jones voted based on his own decision, his own reasons. Black's presence made no difference. Black did nothing, and Jones is responsible just as he would be if Black did not exist. And yet Jones could not have done otherwise, because if he had tried to vote differently, Black would have intervened, would have forced him to vote for the candidate. And so Jones had no alternative, could not have avoided voting as he did, and yet he is responsible. And this shows that responsibility does not require the ability to do otherwise, that the principle of alternate possibilities is false. The structure of Frankfurt cases involves two elements. The person acts on their own, based on their own will, their own reasons, and there is a counterfactual intervener, someone or something that would have prevented any alternative action that ensures the person does what they do. But the intervener does not actually act, remains dormant, and so the person's action is their own, even though alternatives were blocked. And Frankfurt argues that what matters for responsibility is not whether alternatives existed, but whether the person acted on their own, whether their action flowed from their own will. And in Frankfurt cases, the action does flow from the person's own will, and so they are responsible even though they could not have done otherwise. Visualize moral responsibility as depending on the actual sequence, on how the action was actually produced, rather than on alternative sequences on what might have happened, and in Frankfurt cases the actual sequence is normal. The person deliberates and chooses and acts, while alternative sequences are blocked by the intervener. And since responsibility depends on the actual sequence, the person is responsible, and the blocked alternatives are irrelevant. And this shows that incompatibilists are wrong to think that determinism, by ruling out alternatives, undermines responsibility, because even if determinism rules out alternatives, as long as people act on their own, based on their own reasons, they are responsible, and responsibility is compatible with determinism. Critics of Frankfurt cases have offered various objections. One objection denies that the person really lacked alternatives, argues that in Frankfurt cases there are flicker alternatives, tiny alternatives, that remain open until the very last moment, moments where the person could begin to choose differently before the intervener stops them, and these flickers are enough to preserve the principle of alternate possibilities, enough to ground responsibility, and so Frankfurt cases do not refute the principle, only show that responsibility does not require robust alternatives, only requires minimal alternatives, tiny flickers of freedom. Another objection questions whether Frankfurt cases really elicit the intuition that the person is responsible, argues that when we imagine the cases carefully, when we recognize that the person truly could not have done otherwise, our intuition of responsibility weakens, and maybe Jones is not fully responsible. Maybe the presence of Black's intervention mechanism, even though unused, affects responsibility, creates a situation where praise and blame are inappropriate, and this response denies that Frankfurt cases generate clear counterexamples, argues that intuitions are unclear or support the principle of alternate possibilities rather than undermining it. A third objection distinguishes between moral responsibility and blameworthiness, argues that Frankfurt cases might show that people can be causally responsible, can be the source of an action, even without alternatives. But this does not show they are morally responsible, does not show they deserve blame or praise, and moral responsibility requires more than being the source of action, requires the ability to do otherwise, requires that the person had control, and Frankfurt cases do not establish moral responsibility, only causal responsibility. Frankfurt has refined his examples over decades, responding to objections, constructing new variants, and the debate continues, with defenders arguing that Frankfurt cases successfully refute the principle of alternate possibilities, show that compatibilism is correct, that responsibility does not require alternatives, and critics arguing that the cases are flawed, that intuitions are unclear, that responsibility does require alternatives after all, and no consensus has emerged. But Frankfurt's contribution is undeniable, has forced philosophers to clarify what responsibility requires, to distinguish between different kinds of freedom, different kinds of control, and to recognize that the relationship between determinism and responsibility is more complex than simple, incompatibilist arguments suggest. Frankfurt's counterexamples also connect to debates about moral luck, about whether responsibility depends on factors beyond our control. Because in Frankfurt cases, the person is responsible, even though whether alternatives were available was beyond their control, was determined by Black's presence. And this suggests that responsibility is not undermined by factors beyond our control, is not sensitive to luck, and what matters is the actual sequence, how the person actually acted, not whether they were lucky enough to have alternatives. Jones stands in the voting booth, marks his ballot, and Black watches, does nothing, and Jones is responsible, is praised or blamed for his vote, and yet he could not have voted otherwise. And Frankfurt's case challenges traditional assumptions, challenges the principle of alternate possibilities, and forces recognition that responsibility is about actual causation, about whether the person's will was effective, not about whether alternatives existed. And Frankfurt's counterexamples endure as some of the most important thought experiments in philosophy of action, examples that reshaped debates about free will, that challenged incompatibilist arguments, that supported compatibilism, and that remain controversial, remain debated, but have permanently influenced how philosophers think about moral responsibility, about what it requires, about whether determinism threatens it, and the counterexamples persist as permanent features of the landscape, cases that every theory of responsibility must address, must accommodate or explain away. And Frankfurt's legacy includes these cases, these examples that showed that responsibility might not require what we thought it required, might not depend on alternatives, but on something else, on source, on causation, on whether the action flows from the agent's own will. And the debate continues, and Jones votes, and Black does nothing, and the question remains whether Jones is responsible, and Frankfurt says yes. And the counterexamples stand, challenging, probing, revealing complexity in concepts we thought were simple. Hilbert's Hotel Paradox, a hotel with infinitely many rooms, each numbered with a positive integer, 1, 2, 3, and so on without end, stands fully occupied. Every room contains a guest, and yet when a new guest arrives, the manager is not concerned, does not turn them away, because infinity accommodates addition in ways that finite quantities cannot. And the manager simply asks each current guest to move to the next room. The guest in room 1 moves to room 2. The guest in room 2 moves to room 3, and so on, each guest shifting one room higher. And this process, applied simultaneously to all guests, leaves room 1 vacant, and the new arrival is accommodated without displacing anyone permanently. And this is Hilbert's Hotel, a thought experiment devised by the mathematician David Hilbert to illustrate the counterintuitive properties of infinite sets, to show that infinite collections behave in ways that violate ordinary intuition, that they can be put in one-to-one correspondence with proper subsets of themselves, that adding elements or removing elements does not change their cardinality, and that the whole is not always greater than the part when dealing with infinity. The paradox deepens when an infinite number of new guests arrive, an infinite bus pulling up to the hotel, each passenger needing a room, and again the manager is unperturbed, because there is a strategy to accommodate everyone. The manager asks each current guest in room N to move to room 2N. The guest in room 1 moves to room 2. The guest in room 2 moves to room 4. The guest in room 3 moves to room 6, and so on. And this process places all the original guests in the even-numbered rooms, leaving all the odd-numbered rooms vacant. And since there are infinitely many odd-numbered rooms, one for each positive integer, there is exactly enough space for the infinitely many new arrivals who are assigned to rooms 1, 3, 5, and so on. And the hotel, despite being full, has accommodated an infinite number of additional guests without anyone being displaced. The paradox reveals that infinite sets have a property called countable infinity. They can be placed in one-to-one correspondence with the natural numbers, and this correspondence allows for operations that seem impossible with finite sets. A fully occupied hotel with finitely many rooms cannot accommodate additional guests without evicting someone. But a fully occupied hotel with infinitely many rooms can accommodate not just one additional guest, but infinitely many. And this does not mean the hotel was not really full before. All rooms were occupied, but rather that fullness does not prevent expansion when infinity is involved, that the concepts of full and empty take on new meanings in the infinite context. Hilbert's hotel also allows for even stranger scenarios. Suppose infinitely many infinite buses arrive, each bus containing infinitely many passengers, and the hotel must accommodate all of them. And again, there is a strategy. The manager can use a pairing function, a mathematical technique that assigns a unique room number to each combination of bus number and seat number, ensuring that every passenger gets a unique room. And the hotel, starting from full occupancy, can expand to accommodate not just countably many new guests, but countably many groups of countably many new guests. Because the union of countably many countable sets is still countable, and so the total number of guests, after all the buses are accommodated, is the same cardinality as the number of guests before. Both are countably infinite. Both can be placed in one-to-one correspondence with the natural numbers. The paradox challenges intuitions about size, quantity, and comparison, because it shows that infinite sets can be proper subsets of themselves and yet have the same cardinality. The even numbers are a proper subset of all natural numbers, missing all the odd numbers, and yet there are just as many even numbers as natural numbers. Both sets are countably infinite, and this violates the Euclidean principle that the whole is greater than the part, a principle that holds for finite sets but fails for infinite sets. And this failure is not a contradiction, but a distinctive feature of infinity, a marker that distinguishes finite from infinite. Hilbert's hotel also raises questions about the physical realizability of actual infinities, because while the mathematics of infinite sets is well defined and consistent, whether actual infinite collections exist in the physical world is contested. Some philosophers and physicists argue that only potential infinities exist, processes that can continue indefinitely but never reach completion, while actual infinities, completed infinite totalities, are merely mathematical. Abstractions and the hotel paradox, with its fully occupied infinite structure, represents an actual infinity, and if such infinities cannot exist in reality, then the paradox is merely a mathematical curiosity without physical significance. But others argue that the universe may be spatially infinite, that time may extend infinitely into the past or future, and that quantum field theory involves infinite dimensional spaces. And if actual infinities are physically real, then the strange properties illustrated by Hilbert's Hotel may have real-world counterparts. The hotel also appears in theological discussions about divine attributes, because an omnipotent being might be thought to perform tasks that involve manipulating infinite collections. And Hilbert's Hotel shows that such manipulations are logically coherent, that infinity does not lead to contradiction, that an infinite hotel can be fully occupied and yet accommodate more guests. And this addresses worries that infinity is inherently paradoxical or incoherent, demonstrating that infinite structures follow consistent rules, even when those rules differ from finite intuitions. The hotel stands infinitely tall, infinitely long, each room numbered, each room occupied, and the new guest arrives. And there is room, always room, because infinity plus one is infinity, because infinity plus infinity is infinity, because the operations of addition and union that exhaust finite resources leave infinite resources unchanged, and the paradox reveals the strangeness of infinity, the way it defies expectation, the way it makes possible what seems impossible, and Hilbert's Hotel remains one of the most vivid and accessible illustrations of this strangeness, a story that captures in simple terms the profound weirdness of the infinite. And mathematicians use it to teach, to explain cardinality, to distinguish countable from uncountable infinities, to motivate Cantor's diagonal argument and the hierarchy of infinities. And philosophers use it to probe intuitions about existence, about the difference between actual and potential infinity, about whether the physical world contains or could contain infinite structures. And the hotel endures, a fictional place that illuminates real mathematics, a thought experiment that has become a permanent fixture in discussions of infinity, a paradox that is not a contradiction, but a revelation, a demonstration that infinity is not merely a large finite number, not merely an extension of ordinary quantity, but something qualitatively different, something that requires new concepts, new intuitions, and new ways of thinking about size, about number, about what it means for something to be more or less equal or unequal, full or empty. And the guests check in, infinitely many guests, and there is always room for more. Locke's sock paradox. John Locke, the 17th century philosopher, offered a thought experiment about identity and change that has come to be known as Locke's sock paradox, though Locke himself discussed it in the context of broader questions about personal identity and the persistence of objects over time. And the paradox concerns a sock, or in some versions a shoe or a shirt, that is gradually repaired over years until every part of the original has been replaced. And the question arises whether it is still the same sock or whether it has become a different sock. And if it is different, then when did the transformation occur? And this puzzle is closely related to the ship of Theseus, but focuses on everyday objects and the intuitions we have about artifacts, possessions, and the things we use and care about in ordinary life. Imagine a sock that develops a hole, and the hole is darned with new thread, and later another hole appears and is also repaired, and over time the entire sock is patched and repatched, thread by thread, until none of the original material remains. And yet throughout this process the sock has been continuously in use, worn by the same person, stored in the same drawer, and at no point was there a moment when someone discarded one sock and acquired a completely new one. And so there is a strong intuition that it is still the same sock. That identity has been preserved through gradual change. That continuity of use and function matter more than continuity of material. But now consider a variation. Suppose that each time the sock is repaired, the removed material is carefully saved, and eventually someone uses all the original threads to reconstruct a sock, weaving them back together into the original pattern. And now there are two socks, one that has been continuously worn and repaired, containing none of the original material, and one that has been reconstructed from the original material, but which has not been continuously used. And which of these is the original sock? or are both originals, or is neither, and different intuitions pull in different directions. Some say the continuously worn sock is the original because it has never ceased to exist, because there is an unbroken chain of identity linking it to the sock that was first worn years ago, while others say the reconstructed sock is the original because it's made of the original material, because material composition is what individuates objects. And still others say that both have some claim to being the original, or that the question has no determinate answer because identity is vague or conventional. Locke used examples like this to explore the conditions of identity over time, arguing that different kinds of things have different criteria for persistence, that a mass of matter is the same mass if it has the same constituent parts, but an artifact like a sock is the same sock if it has the same functional organization, and a living organism is the same organism if it has continuity of life, and a person is the same person if they have continuity of consciousness and memory. And so identity is not a single uniform relation, but varies depending on what kind of thing is in question. The sock paradox raises questions about artifacts and their relationship to their materials, because unlike natural objects, artifacts are defined partly by their functions and purposes. A sock is not just any piece of fabric, but a piece of fabric designed and shaped to be worn on a foot. And so perhaps what makes a sock the same sock over time is not the persistence of the same material, but the persistence of the same functional structure, the same ability to serve the purpose for which it was made. And if this is right, then the continuously repaired sock remains the original, even after all its material has been replaced, while the reconstructed sock, though made of original material, is a replica rather than the original because it lacks the continuity of function and use. But this view faces difficulties too, because it seems to make identity depend on extrinsic factors, on how the sock is used and perceived, rather than on intrinsic properties. And it raises the question of whether an artifact that is stored away unused for years ceases to be the same artifact, or whether a sock that is repaired and then used for a completely different purpose, say as a hand puppet, remains the same sock or becomes something else. The paradox also connects to questions about personal attachment and sentimental value, because people often care about particular objects, not merely because of their function, but because of their history, because of the associations and memories attached to them. And so a sock that has been worn for decades may have sentimental value that a newly reconstructed sock, even if materially identical, would not have. And this suggests that identity, at least in the context of personal possessions, is partly constituted by historical and relational properties, by the role the object has played in someone's life. And this relational view of identity implies that the continuously worn sock is the original because it has the right kind of historical connection to the person who owns it, while the reconstructed sock is a mere duplicate, physically similar, but lacking the history that gives the original its significance. The sock paradox also raises issues about vagueness and borderline cases because, in practice, the transition from original to replica is not sharp. There is no precise moment when the repaired sock stops being the original and becomes something else. And so perhaps the question of whether it is the same sock admits of no determinate answer. In borderline cases, perhaps identity is vague and the law of excluded middle. The principle that for any proposition, either it or its negation is true, fails for identity statements involving gradual change. The paradox has legal and practical implications as well. In contexts where the identity of an object matters for property rights, warranties, insurance claims, or historical authentication, courts and experts must sometimes decide whether a heavily restored painting or a rebuilt car is the same object as the original or a different object. And these decisions depend on criteria that are often contested, on judgments about how much change an object can undergo while remaining itself. And these judgments reveal that identity is not always a purely factual matter, but involves normative and pragmatic considerations, decisions about what we care about and what purposes our identity judgments are meant to serve. Lockie's sock sits in the drawer, worn and repaired, a humble object that embodies deep philosophical questions, and it reminds us that persistence through time is not as straightforward as common sense suggests, that the boundaries of objects are not fixed by nature, but negotiated through concepts and practices. That identity is a nexus of material, functional, historical, and relational factors, and that the question of whether something is the same thing it was before is often a question without a single correct answer, a question that depends on context, on what aspects of similarity and continuity we privilege, and on whether we are asking about material identity, functional identity, or historical identity. And the sock, like the ship of Theseus, sails on through philosophical discussion, a paradox that will not be mended, a puzzle that remains even after all its threads have been replaced. More's open question, argument why good cannot be defined. A philosopher claims to have defined goodness, claims that good means pleasure, or good means what evolution favoured, or good means what most people approve of, and the definition is offered with confidence, with arguments and evidence supporting it, and yet G.E. Moore, in his 1903 book Principia Ethica, pointed out a fatal problem with all such definitions, a problem so simple and devastating that it has shaped ethics ever since. And the problem is this: take any proposed definition of good, any equation of goodness, with some natural property, and you can always ask a meaningful question. You can ask, but is that property itself good? And the fact that this question remains open, remains intelligible, and not obviously silly, shows that the definition has failed, shows that good has not been captured by the natural property. And this is More's open question argument, a challenge to naturalistic definitions of good that attempts to prove that goodness is indefinable, that it cannot be reduced to any natural fact or property, that it is a simple, unanalyzable concept that we grasp directly through moral intuition but cannot explain in other terms. Imagine someone says good means pleasant, pleasure is what good is, and now More asks the open question, but is pleasure good? And this question makes sense, is not absurd, is not like asking whether bachelors are unmarried men, where the question is trivially answered by the definition. And the fact that we can meaningfully ask whether pleasure is good shows that good does not mean the same thing as pleasant. Otherwise, the question would be equivalent to asking whether pleasant things are pleasant, which is a meaningless tautology. And since the question is not meaningless, since we can intelligently disagree about whether pleasure is good, the definition must be wrong, must have failed to capture what goodness really is. The same argument applies to any naturalistic definition. If someone says good means evolutionarily advantageous, we can ask, but is what evolution favoured good? And this is an open question. Many people would say no, that evolution produces traits that help survival and reproduction, but not necessarily traits that are morally good, that rape and infanticide might be evolutionarily advantageous in some contexts, but are not good, and so the definition fails. Or if someone says good means desired by most people, we can ask, but is what most people desire good? And again, this is open. We can imagine societies where most people desire things that are actually bad, where popular opinion is mistaken, and so the definition fails again. More concluded that good is indefinable, not because we do not know what it is, but because it is a simple, primitive concept, like yellow or existence, something that cannot be broken down into simpler parts or explained in other terms, but must be grasped directly. And we know good through moral intuition, through a kind of perception that is not sensory but intellectual. And different people's intuitions might disagree, but that does not mean goodness is subjective. It might mean that some people perceive moral reality more clearly than others, just as some people have better colour vision, and More's position is a form of non-naturalism, the view that moral properties are real but not natural, not part of the physical world studied by science, but a distinct realm of normative facts that exist objectively. The open question argument has generated enormous controversy. Critics argue that it proves too much, that the same reasoning would show that nothing can be defined, because for any definition, we can ask an open question. If water is H2O, we can ask, but is H2O water? And before we learned the chemistry, this question was open. People could meaningfully disagree, and yet we now accept that water is H2O as a correct identity. Not a definition of meaning, but an empirical discovery about what water turns out to be. And perhaps good is like this. Perhaps good is identical to some natural property, not as a matter of meaning, but as an empirical fact about what goodness turns out to be. And the open question shows only that we have not yet discovered which natural property good is, not that no such property exists. Others argue that the open question argument assumes too much about how meaning works, assumes that if two terms mean the same thing, then they must be obviously synonymous. But this is false. Morning star and evening star both refer to Venus, but it was not obvious. People could meaningfully ask whether the morning star is the evening star. And so Moore's test fails. The fact that a question is open does not prove that the terms do not refer to the same thing. And so the open question argument does not establish that good is indefinable, only that the definition is not obvious, not transparent. And this leaves room for naturalistic theories that identify goodness with some natural property as an empirical discovery rather than a conceptual analysis. Visualize Moore's argument as a test applied to proposed definitions. Each definition is presented, good equals X, and Moore applies the test. He asks, is X good? And if the question is intelligible, if it makes sense to ask, if competent speakers can understand the question and disagree about the answer, then the definition fails. X does not capture what good means. And Moore applies this test to definition after definition. Hedonism says good equals pleasure. Moore asks, is pleasure good? The question makes sense. Test failed. Naturalism says good equals natural property. Why? Moore asks, is why good? The question makes sense. Test failed. And the test seems to show that no natural property can be identical to goodness. That good resists reduction, resists naturalization, stands apart from the world of facts, and refers to something normative, something that cannot be captured by descriptive language. The argument has implications for metaethics, for the question of what kind of thing goodness is. If Moore is right, then moral realism, the view that moral facts exist objectively, must be non-naturalist, must accept that moral properties are sui generis, distinct from natural properties, irreducible to physics or biology or psychology. And this raises questions about how we can know moral facts, how moral properties relate to natural properties, whether moral facts can cause anything or play any role in explaining behaviour. And non-naturalism faces challenges, struggles to explain how we perceive non-natural properties, how they fit into a scientific worldview, whether they're compatible with naturalism about everything else. The open question argument also influenced emotivism and expressivism, non-cognitivist views that deny moral statements are factual claims at all, argue instead that moral language expresses attitudes or emotions rather than describing reality, and these views claim to explain why the open question is always open, because good does not refer to any property, natural or non-natural, but expresses approval or prescribes action. And so asking whether X is good is asking whether to approve of X, whether to pursue it. And this is always an open question, always something we can meaningfully deliberate about. But the non-cognitivists deny Moore's conclusion, deny that goodness is a real property we intuit, argue instead that moral language has a different function, is not in the business of describing reality, but of expressing commitments and guiding action. Moore's argument changed the landscape of ethics, forced philosophers to take seriously the question of whether moral properties are natural or non-natural, whether moral knowledge is empirical or a priori, whether ethics can be reduced to science or remains a distinct domain, and the argument remains controversial. Some see it as a decisive refutation of naturalism. Others see it as a confusion about meaning and reference. And the debate continues, with naturalists proposing sophisticated identities between moral and natural properties, with non-naturalists defending irreducible normativity, and with non-cognitivists denying that moral language describes properties at all. And More's open question sits at the center of these disputes. A simple test that reveals deep issues about meaning, about value, about the relationship between facts and norms, and about whether goodness is something we discover in the world or something we project onto it. And the question remains open, always open, because that is what good does. It resists definition, resists reduction, remains stubbornly normative, always inviting the question, but is that really good? And no answer closes the question, no definition settles it. And More's argument endures as a reminder that ethics is not reducible to any other domain, that the normative cannot be fully naturalized, and that goodness, whatever it is, stands apart, indefinable and irreducible, a primitive concept that we use but cannot explain. Newcomb's paradox, a being with perfect or near-perfect predictive abilities, presents you with two boxes, one transparent and one opaque. And the rules of the game are simple, but the decision is agonizing. And this is Newcomb's paradox, a thought experiment devised by physicist William Newcomb and popularized by philosopher Robert Nozick that has divided decision theorists and philosophers into rival camps for decades. The transparent box contains $1,000, visible and certain, while the opaque box contains either $1 million or nothing, and the amount depends on a prediction made by the being before you arrived. If the being predicted you would take only the opaque box, then it placed $1 million inside. But if it predicted you would take both boxes, then it left the opaque box empty. The being has made this offer to many people before, and has never been wrong. Its predictions are accurate with such consistency that it seems to know the future, or at least to understand human psychology so deeply that it can foresee choices with near certainty. Now you must decide, do you take only the opaque box, trusting the prediction and hoping for $1 million? Or do you take both boxes, reasoning that whatever is in the opaque box is already determined, and you might as well collect the extra $1,000 from the transparent box? The paradox arises because two different principles of rational decision-making give opposite answers, and both seem compelling. The expected utility calculation favors taking only the opaque box, because if the being is almost always right, then taking only the opaque box gives you a high probability of receiving $1 million, while taking both boxes gives you a high probability of receiving only $1,000, and so the one-box strategy maximizes expected value. But the dominance principle suggests taking both boxes, because at the moment you make your choice, the contents of the boxes are already fixed. The being has already made its prediction and either placed the $1 million or not. And since the past cannot be changed, your decision cannot affect what is in the opaque box. And therefore, taking both boxes gives you $1,000 more than taking only the opaque box. No matter what the opaque box contains, and dominance reasoning says you should always choose the option that does better in every possible state of the world. The paradox forces a choice between two deeply held intuitions about rationality: the idea that rational agents should maximize expected utility, and the idea that rational agents should not leave money on the table when doing so cannot possibly make things worse. Philosophers and decision theorists remain divided. Some are one-boxers who argue that the being's predictive accuracy makes the dominance reasoning irrelevant, that the correlation between your choice and the contents of the box is so strong that you should act as if your decision causally affects the prediction, even though temporally it does not. While others are two boxers who insist that causal reasoning demands taking both boxes, that the prediction is already made and your choice now cannot retroactively change it, and that one boxers are falling prey to magical thinking, confusing correlation with causation. The paradox also touches on issues of free will and determinism, because if the being can predict your choice with perfect accuracy, then in what sense is the choice free? And if the choice is not free, then what does it mean to deliberate about it? And if determinism is true, does that undermine the concept of rational decision-making altogether? Newcomb's paradox has inspired the development of new decision theories, including causal decision theory, which endorses two boxing, and evidential decision theory, which endorses one boxing, as well as more exotic approaches like timeless decision theory and functional decision theory, which attempt to handle cases where agents can predict or simulate each other. The paradox remains unresolved, a strange meeting point of probability, causation, choice, and prediction, a puzzle that reveals how little we understand about what it means to decide, and whether the principles we use to navigate an uncertain world are as solid as we believe, or whether they crumble when pressed against beings who can see through us, who know what we will do before we do it, who turn decision-making into a game where the rules themselves are in question. Richard's paradox. In 1905, the French mathematician Jules Richard discovered a paradox that strikes at the heart of how language and mathematics interact, revealing that certain kinds of definitions can generate contradictions no matter how carefully they're constructed. Consider the set of all real numbers that can be defined in a finite number of words using the English language. And this set seems reasonable at first because most numbers we ever think about can be described in some way. Pi is the ratio of a circle's circumference to its diameter. The square root of 2 is the length of the diagonal of a unit square, and so on. Since there are only finitely many words in the English language and only finitely many ways to arrange them into sentences of any given length, there can only be countably many such descriptions, which means there are only countably many real numbers that can be defined in this way. Yet the real numbers are uncountable, as Georg Cantor proved, which means there must exist real numbers that cannot be defined in any finite number of English words, numbers that are forever beyond the reach of language, numbers that exist but cannot be named or described or pointed to in any way. Now comes the paradox. Consider the real number defined as follows. Let it be the first real number in the set of all real numbers that cannot be defined in a finite number of English words, arranged in some standard ordering such as numerical order. This definition appears to successfully define a specific real number, and the definition itself uses only a finite number of English words, which means the number it defines belongs to the set of numbers that can be defined in a finite number of words, but the definition explicitly states that the number belongs to the set of numbers that cannot be defined in a finite number of words, and so the contradiction emerges, sharp and unavoidable. If the number can be defined, then it does not belong to the set of undefinable numbers, but the definition picks it out precisely as a member of that set. And if it cannot be defined, then the definition fails to refer to anything at all, and yet the definition seems perfectly coherent, grammatically correct, and mathematically precise. Richard's paradox exposes a fundamental problem with the concept of definability, the idea that we can cleanly separate describable objects from indescribable ones, because the act of describing the indescribable creates a loop that collapses into contradiction. Some logicians argue that the phrase cannot be defined in a finite number of words is itself vague or improperly formalized, that it mixes informal natural language with formal mathematical concepts in a way that generates confusion, and that a more rigorous treatment would prevent the paradox from arising. Others suggest that the paradox reveals a hierarchy in language, that definitions must be made within specific formal systems, and that talking about all possible definitions requires stepping outside the system into a meta-language, and that mixing these levels is where the contradiction appears. Alfred Tarski developed this idea into a full theory of truth and definability, showing that no language can fully express its own semantic concepts without risking paradox, that truth and definability must always be relativized to a particular formal system, and that higher order languages are needed to talk about lower order ones. Richard's paradox also influenced the development of computability theory, because the question of whether a number can be defined in a finite number of words is closely related to whether it can be computed by a finite algorithm, and paradoxes like Richard's helped clarify the distinction between computable and non-computable reals. The paradox remains a haunting reminder that language, even mathematical language, has limits, that not everything that exists can be captured in words, and that the boundary between the describable and the indescribable is not as stable as it first appears. Synesthesia. Paradox: why numbers have colours and sounds have tastes. A person looks at the number 5 and sees it as blue, not imagines it as blue, not associates it with blue, but actually sees blue, experiences colour as an intrinsic property of the number. And another person hears music and tastes chocolate, hears certain chords, and the taste appears involuntarily, automatically. And these experiences are synesthesia, are cross-modal sensory experiences where stimulation in one modality produces perception in another. And synesthesia is not metaphor, is not learned association, is a genuine perceptual phenomenon experienced by roughly 4% of the population. And the paradox is that synesthetes experience properties that are not physically present, see colours that are not in the stimulus, taste flavours that have no source, and yet these experiences are consistent, are reliable. The same numbers always evoke the same colours, the same sounds always evoke the same tastes, and this reliability distinguishes synesthesia from imagination or association, shows that synesthesia is automatic, is perceptual rather than cognitive, and the phenomenon reveals something fundamental about how the brain is organised, shows that sensory modalities are not strictly separate, but can communicate, can influence each other, and synesthesia represents an extreme of this cross-modal interaction, represents a neural architecture where connections between sensory areas are stronger than normal, are sufficient to produce conscious experiences in one modality when another is stimulated. Imagine being a grapheme colour synesthete, the most common form where letters and numbers evoke colours, and you read this text and every letter has its own colour. A is red, B is green, C is yellow, and the colours are vivid, are as clear as real colours, are not vague or imagined but are perceptually present. And when you see the letter A, you cannot help but see red. The colour is automatic, is triggered by the visual form of the letter, and this colouring happens for all letters and numbers, creates a richly coloured experience of reading. And while this might sound beautiful, it can also be distracting, can interfere with reading when the printed colours conflict with synesthetic colours, can create confusion, and yet for synesthetes, this is normal, is how the world has always looked. And they are often surprised to learn that others do not experience letters as coloured, that the colours are unique to synesthetes. Synesthesia demonstrates that perception is not modular, is not strictly segregated by sensory modality, and in synesthetes there is cross-activation. There are connections between sensory areas that do not exist or are weaker in non-synesthetes, and these connections allow activity in one area to trigger activity in another. And when grapheme area, the region that processes letter and number shapes, is activated, it also activates colour area, the region that processes colour, and this cross-activation produces the experience of coloured letters. And neuroimaging studies have confirmed this, have shown that when synesthetes see numbers color areas of visual cortex are activated, are lit up, and this activation is automatic, is bottom-up, is not produced by conscious thought or imagination, but is triggered by the stimulus itself. Visualize the brain as having sensory areas that are normally separate: visual area, auditory area, taste area, and these areas process their respective inputs and pass information to higher level regions. But in synesthetes, there are additional connections. There are pathways between sensory areas that allow direct crosstalk, and these pathways are the neural basis of synesthesia, are what allows stimulation in one modality to produce experiences in another. And the connections are not learned, are not created through experience, but are developmental, are present from early life. And synesthesia is lifelong, is consistent. The same cross-modal experiences occurring throughout the synesthete's life. The synesthesia paradox is that these experiences are perceptual, are as real as any other perception, and yet the properties perceived are not present in the stimulus. The number 5 is not blue, is black on white, and yet the synesthete sees blue. And this challenges theories that say perception is veridical, is accurate, is a representation of physical reality. And synesthesia shows that perception can include properties that are not in the world, that are generated internally, and yet these properties feel external, feel like properties of objects rather than like internal mental states. And this raises questions about the nature of perception, about what it means for perception to be of something, about whether all perception involves some degree of construction, some degree of adding properties that are not in the stimulus. One theory of synesthesia is that everyone is born with extensive cross-modal connections, that infant brains have connections between all sensory areas, and during development, most of these connections are pruned or eliminated, and sensory areas become more segregated. And in synesthetes, some of these early connections are preserved, are not pruned, and this preservation allows the cross-modal experiences to continue into adulthood. And this theory is supported by evidence that infants show some synesthetic effects, show cross-modal correspondences, and that synesthesia runs in families, has a genetic component, suggesting that genes that regulate synaptic pruning are involved. Another theory is that synesthesia involves disinhibition, involves normally present connections between sensory areas that are usually inhibited, are suppressed, and in synesthetes this inhibition is weakened, is less effective, and so the connections are active, allow cross-activation, and this theory is supported by evidence that synesthesia can be induced temporarily in non-synesthetes through drugs that reduce inhibition, through hypnosis, through sensory deprivation, suggesting that the neural machinery for synesthesia is present in everyone, but is normally inhibited, and synesthetes have less inhibition, have more open channels between sensory areas. Synesthesia also has practical implications. Some synesthetes report that their experiences are useful, provide memory aids, make information more distinctive, easier to remember, and some musicians with sound-colour synesthesia report that the colours help with composition, with understanding musical structure, and some artists deliberately cultivate synesthetic experiences, use them as sources of creativity. And understanding synesthesia has implications for education, for recognising that people process information differently, that sensory experiences vary across individuals, and that teaching should accommodate these differences, should recognise that some students have richly coloured experiences of letters and numbers, while others do not. The phenomenon also raises questions about consciousness, about qualia, about the subjective properties of experience, because synesthetes have different qualia than non-synesthetes, have colour experiences that others do not, and this shows that consciousness is not uniform, is not the same across individuals, and qualia vary, and this variation is not just quantitative, is not just more or less of the same experience, but is qualitative, involves entirely different types of experience, and this challenges theories that say consciousness is universal, is the same for everyone, and supports theories that say consciousness is individual, is constructed by each brain in potentially different ways. And synesthesia is one example of this variation, is one way that consciousness can differ. Some philosophers argue that synesthesia shows that perception is not representational, does not represent external properties, because the colours seen by graphema color synesthetes do not represent anything in the world. The number 5 is not blue, and yet the colour is perceived, and this challenges representational theories of perception, suggests that perceptual experiences are not always representations of external properties but can be internally generated responses. And synesthesia is a case where the response includes properties that are not being represented, and this raises questions about what makes perception representational, whether all aspects of perception are representations or whether some are merely responses are produced by the perceptual system without representing anything external. The number appears black on white, and the synesthete sees blue, vivid and automatic. The colour is as real as the number, is as perceptually present, and yet the colour is not there, is not in the stimulus, is generated by the brain, is a cross-modal activation, and the synesthesia paradox remains: perception includes non-veridical properties, includes experiences that do not correspond to stimulus properties, and yet these experiences are automatic, are reliable, are as perceptually real as any other, and synesthesia endures as one of the most fascinating phenomena in neuroscience. A demonstration that sensory modalities are not strictly separate, that cross-modal connections exist, that perception can include internally generated properties, and that consciousness varies across individuals, includes experiences that are unique, that are not shared by everyone, and the colours remain overlaid on letters, triggered by sounds, evoked by tastes, and the cross-modal world of synesthetes continues, different from the world non-synesthetes perceive, richer in some ways, more confusing in others, and the phenomenon persists.